Let's look at this identity. This identity is for summation of cubes of three variables. So a cube plus b cube plus c cube is equal to a plus b plus c multiplied by a square plus b square plus c square minus ab minus bc minus ca plus this 3abc term. So you can take it on the other side also, and you can write it at the end as plus 3abc. The reason why it has been written here is because many times the application of this equation is such that you'll be given a question where a plus b plus c is equal to 0. When a plus b plus c becomes 0, when this term here becomes 0, then the entire right hand side becomes 0. And in that case, you can write the expression as a cube plus b cube plus c cube equal to 3abc. This is contingent on a plus b plus c equal to 0. If this is given, you can write a cube plus b cube plus c cube equal to 3abc. You should remember this equation, and also remember that when a plus b plus c equal to 0, you will have a cube plus b cube plus c cube equal to 3abc. Now let's look at some questions. So let's look at this question. What we have been given is a plus b plus c is equal to 9, and we have been given ab plus bc plus ca is equal to 23. We have been asked to calculate a cube plus b cube plus c cube minus 3abc, which is the exact term which we noticed in the previous identity. So probably we'll need to use that. So what we need to calculate is a cube plus b cube plus c cube minus 3abc. And we know that this is equal to a plus b plus c, which is 9 in the given question, into a square plus b square plus c square, which we do not know, minus ab plus bc plus ca, which is 23 in this question. So if we are able to calculate the expression a square plus b square plus c square, we should be able to solve this. But how do we get a square plus b square plus c square? And for this, we'll use the identity we studied in the previous video. So a plus b plus c square is equal to a square plus b square plus c square plus 2 into ab plus bc plus ca. Now we can substitute for ab plus bc plus ca from what is given in the question. We know a plus b plus c. We should be able to derive a square plus b square plus c square. So using this, we can calculate a square plus b square plus c square is equal to 9 square minus 2 into 23. I've just substituted the exact values, and that you'll get as 35. Now you can substitute 35 in this expression over here for a square plus b square plus c square. So I'll just continue writing this one over here. We get a cube plus b cube plus c cube minus 3abc is equal to 9 into 35 minus 23, which is equal to 9 into 12, 108. Let's look at another question. So in this question, we have been asked to calculate the prime factors of 343 cube minus 300 cube minus 43 cube. Now if you calculate and then get to the answer, it will be a very complicated process. And that's where you need to remember the identities and you need to know how to apply them. This one can be written as 343 cube plus minus 300 cube plus minus 43 cube, right? And now it's in the format of a cube plus b cube plus c cube. And we had discussed earlier that when a plus b plus c is equal to 0, this will be equal to 3 into a into b into c. Now, is that the case here? It is. 343 minus 300 minus 43 is equal to 0. So we can write this expression as 3 into 343 into minus 300 into minus 43. Once you have reached this level, now it's easy to factorize and identify the prime factors. So you know 343 you can write as 7 cube. 300 again you can write as 3 into 10 square, which is 3 into 2 square into 5 square. And 43 is itself a prime number. So which ones will be the prime factors of this number? 3 will be 1, 5, 7, and 43. So these are the prime factors. Now, if you went ahead and calculated this number, it will be very painful, and the chances would be very low that you would be able to reach the right answer with enough confidence. So this is one question where application of identity helps a lot.